topic 4 is titled Triangle Congruence. In lesson 4.1, we're going to review rigid motions that allow us to write congruent statements. It says if two figures are congruent, a composition of rigid motions maps one figure onto another. We talked about several types of rigid motions, so we're just going to do a quick review in 4.1. Over on the right, it says since Rn of triangle PQR equals PQR prime, then the two triangles are congruent to each other. So let's look in more detail at that type of rigid motion, Rn. Rn just means reflection over line n. Do you remember doing this in topic 3? Oops, that should say over. Reflection over line n. And so P maps to P prime, Q maps to Q prime, and then R just goes to R prime. That's one of several types of rigid motions that we talked about. So over here on the left, here are the other types that we'll use in this lesson. A translation is when we just kind of did a glide on our graph paper. And the notation was a capital T, and then we had a change for X and a change for Y. So we either just kind of added left or right, and we added up or down. The shape stayed the same. A rotation or a turn for the shape was a lowercase r, and we would say an angle measure, like 90 degrees or 180 degrees, and so on. And we always went counterclockwise. A glide reflection, that was a combination of a reflection and a translation. So that could glide across your paper and then flip to go in an opposite direction. So all of these are rigid motions. Suppose there's a rigid motion that maps one figure to another. Why does this show that the two figures are congruent? Well, let's see what's happening here. Notice triangle ABC. The first thing it's doing is it's reflecting over that orange dotted or dashed line to that gray triangle. So as a composition, that would be the reflection over the line x equals -1, because that's what it says right here, of triangle ABC is equal to, and since they didn't label it, we'll just label it A prime, B prime, C prime. So that means C would actually go here on the bottom left, A prime's on the bottom right, and B prime is up at the top. And notice the shape stayed the same, it's just kind of going in the opposite direction. And then up above it says 2 to the right and then -5, and that maps B down to E. So then that would be a translation. 2 for X because you're moving everything to the right, and then -5 for Y. That moves everything down 5. Take that new image in the middle, that gray image, that would be our ABC prime. And that takes us to triangle. Let's see, A would go down to D. B, like we said, went to E. So then C would go over and down to F. And that would be the composition of motions. Now, it says, why does it show that they're congruent? Well, if we look at these side lengths, notice from A to C on that very first triangle, that's 3 units. And D to F is also 3 units. From A to B, that's 4, and D to E, that's also 4. So why does it show? We'll just simply write they are congruent, and we'll just write that congruent symbol, because the sides and angles stayed the same, which is always true with rigid motions. There you go. Here's another example. A 90-degree rotation about the origin maps triangle PQR to triangle LMN. Are the triangles congruent? Yes, they are, because a rotation is a type of rigid motion. And rigid motions keep sides and angles the same. All right, the last one on this page. It's kind of like example 1, but we're going to have to do a little bit of more detective work on this. It says triangle XYZ is congruent to triangle ABC. What composition of rigid motion gets us there? So how are we going from X to A, from Y to B, from Z over to C? Well, taking a look at this, we have to have a composition, which means we're going to have two things that are happening here. What gets us there? Well, that doesn't necessarily mean there's two things, but there are going to be two things here. Notice how X and Z and A and C are all in that same row. So we really don't want to move that. Oh, I didn't want to erase or highlight it. We really don't want to move them too far. But what I would think first, we could take the triangle XYZ and reflect it over this line. It keeps the X and the Z in the same row, but it would drop Y all the way down here right below that -6 to be Y prime. And then this becomes X prime, that becomes Z prime. And if we connect those, notice how that's just the reflection over the line Y equals 2. So if we write that out as our composition, that would be a capital R, Y equals 2 of triangle XYZ, and that gives us triangle XYZ prime. Then we have to figure out, well, how can we go from Z, just kind of hop over to C, and how can we take X all the way over to A, and then Y to B? So let's look at kind of how far apart they are right here. Notice they're only 3 squares apart from X to Z, but we're not going to slide it over that way or glide it. We have to do a reflection because X has to reflect all the way over to A. So if we go right in the middle and do a vertical line, it's actually not on the exact grid mark. It's between 0 and -1. That would be at X equals -1/2. So if we take that triangle and reflect it, watch what happens. X will just kind of hop over to C, and then, let's see, like so. Z would go all the way over to A, and then Y prime would go all the way over to B. Our second reflection would be X equals -1/2. And that would take XYZ prime, and finally get us to triangle ABC. Now we have to be careful in some of these. We want the order of our letters to match location. Like the X angle has to be the same as the A angle. Segment XY has to be the same as segment AB. And they are here. So here's the other part. We have to now write this as a composition, which means we're going to write it out like how you actually would have done those those reflections to get that shape to happen. So when we write out this composition, it's going to look almost like we're doing a glide reflection. Since we did this one first and this one second, do you remember that we write that second one first in the composition, like in how we write out the directions? And then we do that open circle in between. And we say, start with that pre-image, X, Y, Z, and performing that composition of rigid motions, that would get us to triangle ABC. And here we have a second one. Given triangle GHJ is congruent to triangle KLM, what is a composition of rigid motions that would get us there? Well, notice if we're going from G to K, there's my start and there's my start, and then H has to go all the way down to L, and then J has to go to M. So that's how we have to kind of match this up. I'm thinking we're going to need to do a rotation here to kind of turn those letters around and then maybe do a glide to get us down to that spot. Let's try it. Let's try a rotation of 180 degrees. What that does is it takes everything for XY, if you remember this, and just makes them negative. So just changes both their signs, and that would be rotating. So let's see what we have. G is at -7, -2. So then the rotation would put it at 7, 2. Do you remember doing this? 7, 2. So here's where G prime would go. And then H is at -5, 3. So if we do that rotation, that would be at 5 and -3. So 5, -3. There's H prime. And then J is at 0, 3. So we change x and y signs, it's just 0 and then -3. So that just drops down right here like so. That would be j prime. If we connect those, that looks pretty good. And now, this kind of looks similar to the last one that we did on the the one we did on the first page. Now if we just go 2 to the right and down, what, 4? 2 to the right, down 4. Yep, that works. 2 to the right, down 4. That would be a translation. If we go 2 to the right and then down 4, that would get us from GHJ prime to triangle KLM. All right, so now to write out that composition. Let's see if we can do this. Remember we did this one first and this one second. So to write out the composition, we're actually going to write that second one first. So the translation, 2, -4, follows the reflection, or excuse me, wow, the rotation of 180 degrees of triangle GHJ. That's the composition of rigid motions to keep those two triangles congruent. All right, let's try this next one. This one actually won't be so bad. There's only one rigid motion that happens here, which is kind of nice. It says, what composition of rigid motions will map triangle ABC onto ABC prime? So ABC is the orange, ABC prime is the blue. So notice from, let's go from B to B. If I want to go from B at the top, we've got to go left that far and then drop it down that far. So it looks like we're going -5 on the x-axis and counting down 5 on the y-axis. So this would just be a glide or a translation. If we do a translation of -5, -5, that would take our pre-image triangle ABC and map it to triangle ABC prime. And then you could say triangle ABC is congruent to triangle ABC prime. Given triangle ABC, triangle EFG, and triangle JKL, which triangles are congruent? Well, let's take a look here. So I've got A to B. Notice from A to B, if I go up 4 over 1, that would mean E to F. E to F just goes up 4. It doesn't go over 1. So that one really doesn't match. And then J to K goes up 4 over 1. So that would match. B to C goes up 1 over 3. But F to G goes up 2 over 3. So that one doesn't work. That one's definitely not going to be congruent if we're not performing the same kind of, or if we're not getting the same connection for side links as we were from the other two. So we've got B to C went up 1 over 3, K to L up 1 over 3. I think we're good with triangle ABC and triangle JKL. Let's see. Yeah, that looks good. That looks good. All right, carry on. Next one. Is the pair of objects congruent? If it is, describe the composition that gets you there. Well, it looks like a puzzle piece. Notice how this side just kind of flips right over to this one. This missing part would go all the way over to this one. The top piece would match, and that bottom missing piece would match. So it's looking like, yes, they are congruent, but now we just have to figure out how it happens. Well, if we want those pieces to match, notice we're not sliding it across or gliding it across our paper. That means this has to be a reflection. So let's go ahead and draw a line right through the middle, and we'll call it line L. So yes, they are congruent, and the composition or the rigid motion is a reflection over line L, or capital R L. And that would be the composition that would get you from the first picture to the second one. In example B, are the two shapes congruent? Well, it looks like the top and the left side are about the same distance, so that could be close. But then notice there's a piece kind of in this section that's not showing here. So because the shape changes size, the images are not congruent. Okay. All right, last but not least, let's look at example C at the bottom. We've got a lot of little kind of rectangles inside that square shape. From the pre-image to the image, would those be the same? Well, I see the red. The red is kind of vertical in that first picture, but then horizontal in the second one. The green or the blue kind of does the same thing. Horizontal, then vertical, horizontal, then vertical, vertical, then horizontal. So it looks like we have to get the red onto the top somehow, and that blue segment at the top has to go over onto the left-hand side. I'm thinking if we rotate this 270 degrees, that would make that red go up to the top. So if we rotate 270, then the red would be, oh goodness, the red would be kind of on the right-hand side, and we would need it to go to the left-hand side where this image is. So I think then we'd have to also reflect it. So we'll rotate, then reflect. And that's what it would take to get all those little pieces on the inside to match up. For our last example, a boat builder plans to connect two pieces of wood by using a puzzle joint as shown. For a successful joint, each unit must be congruent. So you can kind of see over here on this picture where we want to kind of make those pieces of wood connect. It says, given unit A, what composition of rigid motion maps A to B? So A is the shape on the top left, B is the shape on the bottom left. If they're just kind of gliding down on that kind of shape from one to the other, that would be a translation. But then to get the shape on the other side, from A to C, notice we're kind of doing some sort of rotation to get that top to go to the bottom. That one wouldn't work from A to C as a translation. So just trying to get them to match up using one of our rigid motion options. And these are your notes for lesson 4-1.